let me introduce to you that this is what the new company, the new project, Nuclia, AI search as a service with open source. That and then first, let me introduce myself. For the ones who doesn't know me, I'm mostly an entrepreneur and software engineer. I'm Catalan. I live in Catalonia, in a small city, and I'm also proud, always proud on all the conferences to say that I'm Catalan. I've been in the Plone Foundation and as a member, also as developer on the framework team. And I've been ambassador of free libre open source software since I have 18 years old, and I've been involved in a lot of different projects, and I love open source, and I think it's really the best way of developing software nowadays. And on the professional kind of business side, I've co-founded some startups and some companies, but just to mention Nuclia, that it's my latest project, and Iska, that it's a software agency that uses Plone and Guillotina as a framework to develop solutions. The other guy on the picture is my partner on business. We've built nearly all the companies together, and we've been more than 11 years in this history. So let me explain you why we did what we did. No, and one of the things that we mostly do as people that uses computer, besides maybe breathing, it's to search. No? We spend most of our time searching, and searching is our main. We spend a lot of time every day doing all kinds of searches, even if it's in a CMS, even if it's on an ARP, even if it's on mail. You cannot do anything right now if you don't search. And search, it's super complex problem that it's really difficult that any software that you're developing are really bringing the feedback that you're expecting to the user, because the user is mostly expected to an amazing search quality like Google, where it's able to predict anything that you need for searching, and it's not only keyword search. So we have something that it's really used every day, but we don't have a proper solution to deliver what is expected from this problem. Also, the problem, it's mostly that nowadays our unstructured data is growing a lot. We are storing hundreds of files on Dropbox or Box or any kind of drive or any kind of file storage. And these systems are growing and growing. The amount of textual data, files data, HTML data that we are storing on our systems, it's growing every time more and more. And it's making it much more difficult to find what we are looking for on this unstructured data information. We are also using a lot of multiple languages, and we've seen, for example, in Europe, no, we have a lot of different languages, and we have information across different countries, and we need to search for something. We need to ask in different languages the same kind of keyword, and makes it really difficult to look for what we're looking for. Formats are super different, PDF, but nowadays, most of our information is on videos. This video, this conference I'm doing now, is going to be recorded and it's going to be submitted. And there is a transcription service that is trying to transcribe what I'm saying to being able to index. But this is really because we are doing now on the system. But if you want to push any kind of file, any kind of audio, any kind of multimedia information, you should be able also to search for it. And not only because I'm saying some kind of words or some kind of meaning. We need to be able to search on a lot of different formats. Keyword search, the searching that we are used with Elastic and with Solr and Lucene, that you need to know the word that you're looking for. And in a structured data, when you don't know what you are looking for, you don't know how it's been written on the document, we need to find a way that we are able to search, not by the keyword. We need to search by the question. We need to do a semantic meaning of what we need to look for and be able to find it on our data. That we are lucky that because nowadays technology, nowadays AI allows us to provide searchability using semantic search and using questions. That is the important fact. As engineers and software developers and web developers, we know that it's super difficult to do a scalability and integrations of different softwares to provide this value on our platforms. No, searching, it's complex, and even if you use any kind of the open source services or any of the private services, software as a service, search is super complex, and integration is really the main pain on building this kind of softwares. Then, as I said, AI is the way to fix the problem on the searchability and to be able to find by questions. But nowadays, frameworks to build the AI are super complex. And if you want to deploy, maybe you need to know, you need GPUs, you need a lot of machines to be able to predict this information. Oh, super difficult and super impossible to really provide this value to the client and to bring this to our product. So we said, okay, it's the moment, it's the opportunity to build something that reinvents search. We need to find a new way of accessing information, and we need to make something that it's super easy to be used and super easy to integrate. So that's why we developed Nuclia. And just to go a bit fast, let me show you the architecture of Nuclia. Nuclia is a system that it's mostly composed by 5 different elements. Processing and learning are the parts that are getting the information, normalizing any kind of information, and learning is the side that, in case that you want to fine-tune or provide much more value than the one that we provide out of the box, you can fine-tune your systems. Both of these components are our private service that it's a SaaS platform, and you can use this as API. But it's what most important is that we require to build a storage layer, something that it's used to store this normalized information that provides searchability, and at the same time being able to fine-tune if you want in the future. That's why we created NucliaDB. NucliaDB is an open source database. Yeah, we know that it's not released, and you can imagine we are engineers, we're working really hard to open source it. We really would like to have the repo open source today, but it will be in next days. We still didn't finish to clean up everything, but we will give access to the Python web conference attendees, and at the end of the talk, I will explain you how. So besides NucliaDB, that I'm going to talk a bit later about it, we have also Nuclia Desktop, a component of a web, an electron application that is designed to connect your data sources, even if it's Dropbox, Box, Drive, web pages, any kind of system, to our NucliaDB to be able to process and search. The good thing is that it will be also open source, so anybody can create their own integrations and use the code that we are using to connect to Nuclia. And then finally, we will have an SDK and a REST API to provide easy usage of our API. So let me go really fast onto the processing and the learning sides. Processing, as I said, is a component that structures and structured information with AI. So this normalization process can really inject any kind of file, even if it's a zip, a video, a PDF, a Word, an Excel, even AutoCAD files. You can send to the API, or any kind of link, any kind of URL, text, HTML, whatever you want. And if we don't fulfill it, ping us and we will add, because we want to be able to process any kind of unstructured information, to normalize it to a schema that has the text that is on the content. There is the labels, there is the entities understanding the 15 basic entities that we detect: names, money, dates, location, and you can extend this with the learning API. Vectors are the numeric vectors that we need to have for semantic search. So it already provides you this vector, so you don't need to think about computing anything or even learning about machine learning. So metadata, any kind of piece of information that we're able to extract, and I will go a bit deeper now, and relations of the different elements. The API is super simple. You have a token, and then you can just upload your file. In this case, it's for files. And once you pushed all the files you want, you can send them to process, and you will receive on the pooling side of the API binary message that is a protobuffer message that you can deserialize with our NucliaDB Protos Python package that's in PyPy. This is the low-level API that is designed to normalize these files, even if it's a PDF or a video. For example, PDFs. We can extract the language, any kind of metadata from the file, nested information, nested files on the images, a preview, the different pages, the pages preview, the thumbnail, the small image of the PDF, all the possible text, the vectors that they already explained, the links, each paragraph that there is on the text that you can really detect the paragraph, all the entities that we detected, all the possible classifications, and a summary of the PDF. But what happens if it's not a PDF, if it's a video? Then we are able also to deliver the video in a streaming format, and the paragraphs has the second, or where it starts each of the paragraphs on the video. So when we do semantic search, you can really point the user to the really precise second where this sentence is going to happen. So this is the processing side. The learning side, it's once you have all this data that it's been normalized and it's stored on NucliaDB, we are able to fine-tune it and to improve the accuracy, or even add more entities or more labels that you wanna detect. But we are even going a bit much further on this side, and we are creating TensorFlow.js models that you can use on your browser or any JavaScript application, so you can detect the intent without really needing to have any backend service providing the prediction. We are working hard here to provide much more algorithms, question answer, conversational and algorithms based on all the data that we have on NucliaDB. Now, let me focus on what I'm super proud. I'm really happy that we took the decision to build it. NucliaDB. It's an open source database fully designed for this unstructured data. A database that it's based with the main concepts of storing NoSQL data, but providing an embedded system to index it with proper indexing technologies. So in order to build this database, we first needed to know what we are. No? And we said, we love Python. Yeah, I've been loving Python maybe also since I went out of college, and I've been on all possible versions of Python, and I'm really, really happy about how Python has evolved during the last years with async.io and the way of providing more tools to improve the performance of Python. Even when I built Guillotina and I've been on the Plone Foundation, I'm really super excited about what Python is being able to do, no? And the limits are endless, and you can even build databases with it. But it's clear that you need Rust for really performant sides of your application. For example, our indexes, the ones that requires to search super fast and give an answer in less than 20 milliseconds needs to be Rust, because it's more optimized from the low level and it provides much better performance on these really performance critical tasks. Once we have these two languages clear, that we wanted to build with only these two languages and focus on these two languages, we know that we wanted something that is reliable and scalable, easy to use, and that has this index that it's multimodal, that it's able to index text, vectors, relations, in a way that it provides a really fast answer. So it's a really difficult problem to build something like that. And with nowadays platforms that already exist that delivers some of the values that we are fixing, it was really difficult to try to evolve them to be scalable, cloud optimized, and easy to use. So that's why I met this guy, Carlos. Carlos is an old friend of mine that we already been working for, I don't know, 10 years or so. And I came to him and said, Carlos, we need to build something that is scalable, distributed, and that really fulfills the requirements of an NLP database. And he was, oh my God, this is super difficult. How we are going to do it? We are a startup and we need to go fast, and this is not possible. So we took a strategy. First, we took the decision that we wanted to build it open source because we want people to be able to join us and contribute and affect on our application. But we also wanted to have a first version that it's fully working so people can onboard it and have a good experience on it. So we are building the first version and then we are going to open source. We already have the first version. We are cleaning the code and making sure that it's all linted, all MyPy, all super tested. So we have a good status, a beginning status. And in order to build it, we say, okay, let's divide and conquer the problem. It's a standard strategy. So the first thing was, let's decide which layers we are going to use from external projects, okay? Here, we took the first decision. It's we want read and write separated. Because for us, what matters a lot, it's the reads. We want to provide a really good, fast search experience. And the writes, well, it would be great to have the same experience on writes, but we know that there is a compromise. You cannot do everything that you want if you want to distribute the system. But so we will deliver eventual consistency with the slow writes and fast reads. Then we needed something to provide the transactionability, and that's we based on the commit logs strategy for the streams, and we are using NATS and mostly the newly stream system from NATS that's called Jetstream to connect all the streaming and all the pipelines of our database. Then we wanted something to store large files, binary files, and we said, let's reinvent the wheel. We have GCS, S3, and Azure File System, and for open source on-premise deployments, we have Minio. So we are based on this file storage. As we also say that we don't need to build a key value. There are a lot of them, and there are a lot of them that are really good. So we said, let's reuse a distributed key value, that's TAKV, but we also support Redis for standalone deployments. Then for cache and invalidation, we decided that we're going to use Redis and Memcache, that we already had a lot of experience. And we needed something to connect all these components in one. And that's why we developed the first SUIM implementation that is compatible between Python and Rust. So you can have Rust components and Python components in the same cluster. And it's also going to be open sourced on the NucliaDB repo. So we are super proud to have this to interconnect all these components. So with these ideas in mind, we needed to develop these components. These components are separated from the top to the down to the API level to the indexing level. So on the top, we have the writer, the reader, and the search that are the APIs that fulfills the writing, the reading of the different information and the searchability experience. We also have one component called one that interconnects and that have all of them in one package so we can have a standalone deployments. The ingest is our transaction engine. It gets all the information from the writing and provides the serialization onto the nodes. And the nodes are the indexing services that has the information distributed across different shards. In order to connect everything, as I said, we developed the swim that connects the search components, the ingest components, and the node components. So before going deeper into this site, let me try to explain how is the logical distribution of information on NucliaDB. First, we have the knowledge boxes. The knowledge boxes are the containers where we push all the resources. And in the knowledge boxes, we are able to store entities. Entities can be the ones that we already provide of the box, or the ones that the user can define through our UI to fine-tune it and to improve more entity structure. Labels, it's the categories from the paragraphs, from the documents, from the fields that you can assign to them, or you can expect the AI to detect for each one of these components. You can define the ontology to define these labels with a different label set. Widgets, it's also an element which provides a super interesting way of defining UI elements that you can plug on any static HTML or any kind of JavaScript application. You just push the information on NucliaDB, you create this widget, and this widget can be embedded on any site. You can have a better or more advanced experience with the API by itself, but we also wanted to provide a super no-code experience so people can embed anywhere. And finally, yeah, the resources. The resources are one of the most the center of this knowledge box, and each one of these resources has different kind of fields. You can have file fields, layout fields, links fields, text fields, and conversation fields. Any of these fields are then sent to the processing API to be normalized and then getting back to the system to be stored and to be indexed properly. You can also use it as a source of truth, or you can use only as an indexing, just sending information and asking not to be stored. So these are the resources, the center of the knowledge box. And here we have the definition of the different components that I'm going to talk. First, the simple ones, the API ones. Writer, reader, and search are fast API, and the models are designed with Pydantic and nothing strange, nothing super complex. It's just a way of defining all the API. It's also the writer is responsible of sending all the messages to the processing API. The reader and the search is responsible of sending the information to the learning API in case we need to predict the intent or convert a text to a vector to search on our vector database. And the search API is the one responsible of doing a distributed search across all the nodes and to merge the results. On the ingest, this transaction component that we have in the middle, it's responsible of having the commit log to receive everything and protobuffer messages and to serialize it onto the database, on the blob storage, to merge everything incrementally, and to provide a structure to be sent to the indexes to index the information that needs to be indexed. It's also responsible of pulling the results from the processing API. Let me present another guy. This is an history about people, because building this kind of projects requires a lot of smart people, and I'm super happy to have them on the team. He's Herme, is a PhD on computer science, and he's super smart at Rust, and he's one of the chief of the node itself. The node is the lowest indexing structure. And I came to Herme and I said, okay, Herme, what do we need to build to have a really fast answer with 4 different kind of indexes? And he said, okay, let's do the same pattern. Let's split read and write on 2 different processes, and even have a sidecar that connects to the stream that needs to be indexed and inject onto the reader and the writer. By this way, it's super easy that then the query can be super fast and just be optimized for answering queries super fast. Each one of these nodes has shards, And each shard has a BM25 index and a fuzzy search index that is based with a Tantiby, a Rust Lucene implementation, with an HSNWB index that we built ourselves, that it's designed for go super fast on the searchability of the semantic search. And we are finishing to build the relation graph to provide searchability with the traversal navigation and by closest nodes relation between different entities, different labels, and different entities. So all this system, the AP, the writer, the reader, the search, the ingest that provides the transactionability, and the nodes itself that provides the indexing information are super interesting, and they scale really fast. They are able to hold lots of different documents, millions of documents without any problem. But nothing of that will be useful if we don't have a good API. Because as I said at the beginning, for us, it's super important to have an easy to use API that it's able to integrate and fulfill in a lot of different use cases. So that's why, let me introduce you, the last two guys I'm going to introduce you. Well, Eric and Anna, they are the sheriffs at the project. They come to the API, and every day they are asking to be more easy to use, more user-friendly, with a better developer experience. And they are our developer advocates, and they are going to make our lives help and all the team to make sure that it's easy and as scalable as we really want to have. So from the API point of view, we really have a few headlines that needs to be easy to use. We want to be low code, because we really want that this technology, it's really able for any kind of project, even if it's small, even if it's big, we don't care. We want to have the option to have a widget that you deploy on your static web page, or you can build your own integration with a really complex system. We also want to have this desktop application that provides easy synchronization, an API focused on resources and fields, and a proper SDK and SDK UI. The API is super simple. You have the resources, you push the data. In this case, for example, is the way to push a URL. You just call resources, you push any URL you want to be indexed, and the system will index everything on that URL, provide all the entities, all the magic we say, and store in a way that on a NucliaDB, even if it's cloud, because we also provide cloud hosting of the Nuclia, or you can provide your own, you can download the NucliaDB and use it on your laptop or in your servers, and just the same way that you would use on our cloud. And you can send this URL to the NucliaDB. It will be sent to process, get the normalization, and being able to search on it with all the 4 different indexes that we have. If you want to push a file, it's super simple, knowledge box / upload, and push the binary file. You can define a lot of metadata through headers, but you can check the documentation for that. The search endpoint, super simple. Search, you do the query, you can ask which kind of features you want to have. You want to have only paragraphs, you want to have fields, you want to have the sentences, you can have all at the same time, and it provides you the response with all everything merged and just with pagination, so you can define what kind of information you want to see and which metadata you want to see for each file, for each object. So just as a premiere, because it's been quite new online, docs.nuclia.dep, it's our developer portal. We are building it. Super happy to receive feedback about any kind of information that it's missing. We are working hard to fulfill with different use cases. There is a full automated from the code reference that we built automatically on each commit. So it's always up to date with the latest API. And I really hope that it's useful so you can build everything that you want. And just to also end my talk, and then I'm going to answer. I see there is a question here. We are hiring. If anybody is interested in contributing with an open source project like this, feel free to send your information on nuclia.com/careers. We are a small team. We are 11 people nowadays, but we really want to grow a lot because our project is super ambitious and we really want to build something really big. So even if you are a Python developer, a Rust developer, a machine learning engineer, or an operation manager, feel free to ping us and we will be super happy. And yes, now it's the moment, and I'm not going to take it more longer. If you want to have early access to the NucliaDB open source code, and if you want to have early access to the Nuclia API on our platform, feel free to fulfill this form. We will open source it in really few amount of days. It's just a matter of days now. It's been a really hard work, and I'm sad that it's not everything open source today yet. But it's, as I said, we are working really hard to make it in the next days. If you want to have early access, you have here the URL. And yeah, I think that it took me much less than I was thinking. I'm super open to answer any question. I see that there is a question from Michael. The interconnection nodes, can that scale without an complexity? Well, it scales a lot because what we are doing at the end, it's distributing and sharding and replication everything. So at the end, how big you are scaling, it may affect the performance on the search and not getting all the results that you may want. We are working hard to provide the best, but we are in the process to get to it. Right now we tested with 10 million documents and we were able to search super fast.